Hello everyone, and this is Sandeep. You are watching Samyans Academy, and in this session we are going to discuss about current electricity. And let us start now. So, what is electric current? So, electric current is expressed by the amount of charge flowing through a particular area in unit time. Suppose now this is a particular area, and this is a particular area. So, in this particular area, some charge is flowing through this particular area in unit time, and it is said to be electric current. Okay, and uh, before giving the electric current to this any conductor, all electrons moving in the random direction. Okay, so when you apply the battery source to any electric current conductor, the electrons moves in the direction from the negative terminal to positive terminal of the battery across the conductor in unit time, and this is said to be electric current. Okay, come to the definition here. Electric current is expressed by the amount of charge flowing through a particular area in unit time, and also we can call as it is the rate of flow of electric charges, and it is rate of flow of electric charges also we call as electric current. So how we can take the direction of the electric current? Now you see here in this conductor, observe here, these electrons are moving from the negative terminal of the battery to the positive terminal of the battery. Okay, then electrons are moving from negative to positive. Then conventional current direction, you have to take the opposite to the direction of the flow of electric current, a flow of electrons. Okay, so electrons are moving from negative to positive, then current is moving from the positive to negative. So in this way, you have to take the direction of the electric current. Now, conventionally in electric current, the direction of electric current is taken as opposite to the direction of flow of electrons, so which are negative charges. Then how do you define the electric current? Suppose some amount of charge is flowing through a particular unit time. So how much amount of charge is flowing through this? Q amount of charge is flowing, and in which in how much time? In time t. Okay, then I equal to Q by T. So by seeing this formula, we can define this. If a net charge Q flows across any cross section of a conductor in time t, then current I through the cross section is I equal to Q by T. So by using this formula, we can derive the I equal to Q by T. So where Q is the charge, so Q charge is flowing to the particular time t. So this is said to be current I. Is it clear, everyone? And move on to the next one. Now you see, next here, what is the SI unit of electric current? So SI unit of the charge is here coulomb, and SI unit of the current is ampere. Then how do you calculate the 1 coulomb of charge consists how many electrons? So 1 coulomb of charge consists how many electrons? Already you know that. What is the charge of an electron? What is the charge of an electron? That is equal to 1.6 into 10 to the power of minus 19 coulomb. This is the charge of an electron. Means one electron is having the charge 1.6 into 10 to the power of minus 19 coulomb, means 1 coulomb of charge consists how many number of electrons. Then how do you calculate this? By using this total charge equal to Q equal to 1 coulomb, and the number of electrons, we can use this formula, number of electrons equal to total charge by charge of each electron. Okay, so number of charge equal to here how much? Here 1 coulomb. 1 coulomb by 1.6 into 10 to the power of minus 19. So this will give you 6.25 into 10 to the power of 18 electrons. Means in this 1 coulomb of charge consists how many electrons? 6.25 into 10 to the power of 18 electrons. Right? Then how do you calculate this? Already you know this. This calculation is simply we can say like this. So 1 electron is having the charge 1.6 into 10 to the power of minus 19 coulomb. Then 1 coulomb of charge consists how many electrons? So just you do the cross multiplication, 1 into 1 by 1.6 into 10 to the power of minus 1. So this will give you the value, how much it is? 6.25 into 10 to the power of 18 electrons. Means 1 coulomb of charge consists how many electrons? 6.25 into 10 to the power of 18 electrons. Is it clear, everyone? And move on to the next one. Next here, unit of current. The electric current is expressed by a unit called as ampere. So how do you define the ampere? So 1 ampere, already you know that. What is the current formula? I equal to Q by T, right? So 1 ampere of current, when will you say this 1 ampere of current? If 1 coulomb of charge is flowing through in particular area of any conductor in 1 second of time, and this is said to be 1 ampere of current. Is it clear, everyone? So I means here, what is the current unit? Unit of current is ampere. So 1 ampere, how to define? So 1 coulomb of charge flowing through a particular area in 1 second of time, then it is said to be 1 ampere. So 1 coulomb of charge consists how many electrons? Just now we discussed. What is that? Yes, that is 6.25 into 10 to the power of 18 electrons. Okay, so this many electrons, 6.25 into 10 power 18 electrons. Do you know that 10 power 3 is 1000, 10 power 4 is 10,000, like that 10 power 18 electrons, 6.25 into 10 to the power of 18 electron, which constitute 1 coulomb of charge. And this many electrons are flowing through the any cross section area of conductor in 1 second of time. And this is said to be 1 ampere of current. In 1 ampere of current, how many electrons are flowing in the 1 second of time? Then you have to tell your 6.25 into 10 to the power of 18 electrons. If 6.25 into 10 to the power of 18 electrons are flowing through any cross section of area of conductor in 1 second of time, it is said to be 1 ampere. Then how to define the 1 ampere? Let us see now. The electric current is expressed by a unit called ampere. Then definition of ampere is 1 ampere is constituted by the flow of 1 coulomb of charge. Okay, flow of 1 coulomb of charge per second. So this is we called as 1 ampere of current. Here we have the units, different units of the ampere. So milliampere is there, microampere is there. So what is milliampere? So milliampere equal to 10 power minus 3 ampere, and microampere equal to 10 to the power of minus 6 ampere. Is it clear, everyone? And move on to the next one. Then how do you measure the electric current? Then by using the ammeter, so we can measure the electric current. Then how do you connect this ammeter? Ammeter we have to connect in series, right? Now you see, then an instrument called ammeter. So this is given in figure. So now you see, this is a figure of ammeter. Okay, here this ammeter measure the current in milliamperes. MA is there, so 1 milliampere equal to 10 power minus 3 ampere. Okay, now this is an instrument called ammeter, which measures the electric current in a circuit, and it is always connected in the series in a circuit through which the current is to be measured. Okay, by using this ammeter we can measure the current in the circuit, how much current is flowing in the particular wire or particular circuit. Now here we have the definition of electric circuit. Then this is the electric circuit in our household things, and this is arrangement in the series connection. And here we have the battery, and this battery is connected to bulb, and this bulb through this bulb, and this wire is connected to ampere, and the current is flowing through this bulb, and also it is flowing through the ampere, and it will flow through the switch key. When switch is on, this current is flowing and this circuit is complete. So this bulb can glow, and the ammeter measures the amount of current. This total setup we called as electric circuit. Then electric circuit comprising a cell, that is an electric bulb, an ammeter and plug key. So note that, so here electric current flows in the circuit from the positive terminal of the cell to the negative terminal of the cell through the bulb and ammeter. How that electric current is flowing in this circuit? From which terminal to which terminal it is flowing? From positive terminal to negative terminal, and it is flowing through the bulb, ammeter and switch key. And this total setup we called as electric circuit. We can see this electric circuit like this. Now you see, this is the electric circuit, and this is a battery source, and this is the positive terminal, and this is the negative terminal. The current flows from the positive terminal to negative terminal through this bulb, through this switch key, like this. Again it will come to here. Like this, one circuit is completed now. Okay, in this circuit the current is flows when this switch is on. Is it clear? Now this is the actual setup. This is our battery, 12-volt battery. Sorry, this is a 9-volt battery, and which is connected to the bulb, and this bulb again connected to the switch key. From this current is passing through here into reaches to the negative terminal of the battery, and this is said to be electric circuit. Is it clear? Move on to the next one. Here we have a question based on the I equal to Q by A formula. Let us see what is this question. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. Here we need to find out the amount of charge. How much current is flowing? How much current is drawn by the filament here? Filament of an electric bulb. So here bulb is there. The bulb is taking how much current from the circuit? 0.5 ampere of current. Okay, and it is glowed for how many minutes? 10 minutes. So bulb is switched on for 10 minutes. then find the amount of electric charge that flows through the circuit. So we need to find the amount of charge, how many coulombs of charge passing through that bulb in particular 10 minutes of time. Then how do you calculate this? Now you see here we have the current. What is the I current value given here? 0.5 ampere. Is it clear? Then how much time it is the current is flowing through this bulb? That is time 10 minutes. Always remember this minutes you have to convert into seconds. 1 minute equal to how many seconds? 60 seconds. When 10 minutes constitute how many seconds? 10 into 60, which is equal to 600 seconds. Okay, then you have to find the Q value. Okay, now what is the formula for finding the current? I equal to Q by T. What is that? I equal to Q by T. So we need to find Q equal to I into T. What is the I we have here? 0.5. 0.5 into time is how much here? 600 seconds. So 0.5 into 600 is 300 coulombs. Okay, the charge, the amount of charge flowing through this bulb in particular area is called as 300 coulomb. Is it clear, everyone? Okay, now move on to the next one. Now here these are the some in-text questions from your textbook. What does an electric circuit? Just now we discussed a continuous and closed path along which an electric current flows is called as an electric circuit. Okay, and the electric circuit is a closed path in which the current is flowing continuously. Okay, from bulb, ammeter, whatever you connect in that circuit, the current is flowing all that equipments or all that bulb or ammeter or switch key. So now we have here define the unit of current. Already we defined that. So unit of current is 1 ampere. So how do you define the 1 ampere? So 1 ampere of current constitute how much charge? 1 coulomb of charge flowing through a particular area in 1 second of time. It is said to be 1 ampere. Then unit of current is ampere. If 1 coulomb of charge flows through any section of a conductor in 1 second, then the current through it is said to be 1 ampere. Okay, I equal to Q by T. So 1 ampere equal to 1 coulomb per second. Then units of the ampere is 1 ampere equal to 1 coulomb per second. That means 1 coulomb of charge flowing through a particular area in 1 second of time. It is said to be 1 ampere. Okay, already we have done this. Calculate the number of electrons constituting 1 coulomb of charge. Can you tell 1 coulomb of charge consists how many electrons? Yes. Yes, very good. That is 6.25 into 10 power 18 electrons. Okay, nice. Next one, electric potential and potential difference. Okay, before going to electric potential, you have to know that. So already you know that water flows from high altitude to low altitude. Air flows from high pressure region to low pressure region, and water flows from high pressure region to low pressure region or high altitude to low altitude. In this way, then how this charge flows? How this charge flows in the electric circuit? Okay, we have to give some energy, right? We are paying the bill to the electricity department for giving some energy. So what they will do, they will give the charge, they will give the force to push the charge in the electric circuit, and they are giving some energy. Okay, because of that energy, a charge is flowing in our circuits. Okay, now you see here electric potential difference means, then how do you understand this electric potential? Let us see, here the wire is there. Okay, here we have the 2 points. Let us see, this is a point A and this is a point B. Here we have some charge. Let us see, here we have the some charge. Let us say this is a positive charge, and let us say this is the value of charge is Q, and this charge has to flow from the point A to point B. Then how it will flow? So you have to give some energy, yes or no? The water flows from the high altitude to low altitude, and air flows from the high pressure region to low pressure region. Similarly, then how the charge will flow? Charge will flow from high potential region to low potential region. This high potential region, let us say this is a positive terminal of the battery. Low potential of the region, that is said this is a negative terminal of the battery. Then charge flows from high potential to low potential. Okay, now which one is you consider here high potential? Here A you have to consider as high potential, and B you have to consider as negative potential, that is a negative terminal of the battery. So then charge flows because of this high potential to low potential, the charge experience some force on it. Because of that force, the charge moves from the point A to point B. Is it clear? Now you see the definition of the electric potential. Vision. The electric potential difference between 2 points is an electric circuit carrying some current as a work done to move in a unit charge from one point to the another. So we are doing some work, right? No, not we are doing. So here electric circuit, battery is doing work, right? So battery, how that battery is doing work now? The some work is doing, for what purpose the work is doing here? The charge we have to move from the point A to point B. Then the work done to move this unit charge from one point to another point in an electric field is called as electric potential, and the difference between these 2 points we called as potential difference. Is it clear? Then this potential difference between these 2 points we can define as work done on unit charge. So V equal to W by Q. So W here, work done on unit charge to move this charge from one point to another point. Okay, and the SI unit of electric potential difference is volt. Okay, then 1 volt, how we can define? Here 1 volt we can define as 1 volt is the potential difference between the 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to the another. Means, how do you define the 1 volt here? So 1 volt we can define as, already know that, so V equal to W by Q. By using this definition we can easily define this. So how much work is done to move the 1 coulomb of charge? 1 joule of work. Okay, 1 joule of work is done to move 1 coulomb of charge from one point to the another point is said to be 1 volt. Is it clear, everyone? So 1 volt, how we can define? So 1 volt is the potential difference between the 2 points in a current carrying conductor. So it is a potential difference between the 2 points. So this is a potential difference between the 2 points. So in this the current is flowing. Okay, it's a potential difference between the 2 points in current carrying conductor when 1 joule of work is done to move 1 coulomb of charge from one point to another point is said to be 1 volt. Okay, we can easily remember like this. By seeing this formula also we can tell. So 1 volt equal to 1 joule by 1 coulomb, right? So W, units of work, equal to joule, and units of Q equal to a charge equal to 1 coulomb, right? 1 volt we can define this like this: 1 joule of work is done to move 1 coulomb of charge from one point to the another point. Or, and this is happening in these 2 points, between the 2 points. Okay, and you start from here. The 1 volt is the potential difference between the 2 points carrying some current. So this wire is carrying some current. So this is the potential difference between the 2 points. So it is said to be 1 volt. When we said to be 1 volt, it is when 1 joule of work, 1 joule of work is done to move this charge, move this charge from one point. How much charge it is moving? 1 joule of work we are doing here to move this 1 coulomb of charge. The charge value is how much here? 1 coulomb of charge from one point to the another point is said to be 1 volt. Okay, in this way we can define this. Now to measure the voltmeter, to measure the potential difference, we have the voltmeter, and this instrument we called as voltmeter. And always remember this: voltmeter you have to connect in parallel in the connection, ammeter you have to connect in series in the connection. Okay, then potential difference is measured by the means an instrument called the voltmeter. The voltmeter is always connected in parallel across the points between which the potential difference is to be measured. Now you see, here we have the electric circuit and here we have the bulbs. Okay, how we are connecting this potentiometer, voltmeter? This is a V1 is a voltmeter, right? So we are connecting this parallel to the connection. So this is said to be parallel connection. Okay, and these are the voltmeters. This is a voltmeter. By using this multimeter also we can measure the current, and we can measure the volt difference, potential difference also we can measure by using this multimeter. Okay, and these are the some instruments we can use to measure the potential difference in the circuit as well as current in the circuit. And this is said to be ammeter. So volt, this is a multimeter. Multi means we can measure the current and also we can measure the potential difference between 2 points. Okay, and one special instrument also there to measure the only voltmeter, and this is a voltmeter. Okay, this is always we have to connect it in the parallel in the circuit. Is it clear, everyone? Okay, and move on to the next one. Here we have one question. Already we have done this. Okay, then move on to the next question. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volts? Already you know this formula. what is the given things here? Okay, how much work is done to move a charge of 2 coulomb, then q value is how much they given? Q value is 2 coulomb. Okay, and across the 2 points having the potential difference is 12 volts. Okay, what is the potential difference we have here? 12 volts. Then we need to find the work done. Work done is how much? Okay, we have the formula, one voltage potential difference between any 2 points equal to work done on unit charge. Okay, W by Q. From this you have to measure the work. So work equal to V into Q. What is the V value? V value is 12, right? And Q value is 2. 12 into 2 is how much? 24 joules. And work done to move the 2 coulomb of charge is how much here? 24 joules. So in this way we have to calculate. So next question, how much energy is given to each coulomb of charge passing through a 6-volt battery? Okay, here energy means work done. So work is nothing but energy. Work and energy are the similar terms. Okay, how much energy means we need to find the work only. Okay, don't get confused here. Right. So now, how much energy is given to each coulomb of charge passing through a 6-volt battery? 6-volt battery. So now you see each coulomb, then charge value is how much here? Q equal to 1C. Okay. And now you see this is voltage. Voltage is how much here? 6 volts. Okay. Then we need to find work or energy. Both are similar terms. Don't get confused here. Okay. Then already we know the formula. V equal to W by Q, then W equal to VQ. Okay, then what is V here? V is 6 volt, Q is 1. So 6 into 1, how much it is? 6 joule. Okay, this is said to be how much energy is required. So 6 joules of energy is required to each coulomb of charge passing through the 6 volt of battery. Okay, move on to the next. And these are the some symbols of commonly used circuit diagrams. And electric cells we have to measure like this. This is a positive terminal of the battery and this is negative terminal of the battery. Remember, when you represent this positive terminal you have to represent with the big line. Okay, negative terminal you have to represent with the small line. Okay, this is a positive terminal, you have to represent with the length of the line is bigger than this one, right? So positive terminal indicates with the bigger line and negative terminal indicates with the smaller line. Now here we have the, this is the electric cell and only one battery. When you take only one cell, okay, that is indicated with plus and minus. Battery is a combination of many cells. Battery is a combination of many cells. When you combine like these cells many in 2 or 3, more than 2 or 3, and it is said to be battery. Then how we can connect one battery to the another battery? You see here. Now here we have the connections in the given second diagram. So positive terminal and negative terminal like this. The negative terminal of the first battery, when it is connected to the positive terminal of the other battery like this. Okay, so in this way you have to connect like this. Okay, next one, negative terminal of this battery connected to the positive terminal of the another battery. When you connect like this it will go on like this. Okay, and combination of these many cells give the battery. Okay, so the single cell we can define like this. This is a single cell, it's not a battery. So this is a cell. Combination of all these cells will give the battery. Okay, and this is a plug key. When switch is open you have to represent this open back bracket. Okay, so then switch is closed, then switch is closed means you have to put one dot in between the brackets. This indicates switch is closed. Okay, and when you join the two wires like this, so this is said to be like this. Okay, this is a joining of wire, we can represent like this. If one wire is crossing over another wire, so this represent like this. Okay, one wire crossing over another wire, so you have to represent like this. Okay, this is a symbol. Then how do you represent the bulb? So this is a symbol of the bulb. So we can, yeah, this is a symbol of the bulb and this is a symbol of the bulb. Okay, by using this symbol we can represent the bulb. Okay, and this is a symbol of the resistor. Why the given speed breakers here? Here we have so many speed breakers, right? Okay, so why these speed breakers indicates? So what is the meaning of this speed breaker? Now you see, when road is having full of speed breaker, then what is the speed of our vehicle? It is somewhat reduced, right? Suppose in the electric circuit any instrument is there, so that is bulb or it may be fan or it may be electric iron or it may be anything, right? It will use some current. Okay. Okay, when flowing through any circuit or any component, what happened, the charge is utilized by that component, so that the charge gets slowed down. It will move very slowly. Why? Because this resists the flow of electric current. This indicates resistance. All speed breakers are there. Resistance means, and it will oppose the flow of electric current, or it will oppose the flow of electrons. Okay. So that we can represent, that we can study detail in the further. Now you see the symbol of the resistor is like this. Okay. And when you put like one arrow mark here, so this will indicates variable resistor. By using that knob we can change the resistor value. Okay. And this is a variable resistance, and also we called as rheostat. And ammeter, then how do you represent the symbol of ammeter? Just you draw the one circle and you draw a letter, and from in the next side, sorry, and this side you give the positive terminal, and this side you will give the negative terminal, and this is a symbol of ammeter. Then voltmeter, how will you represent? So you draw the one circle, you write V letter, and this is a positive terminal, and this is a negative terminal of the voltmeter, and this is a representation of ammeter, voltmeter. In this way you have to represent the some electric components. So these are the commonly used components in the circuit diagrams. Okay, and move on to the next one. Here Ohm's law is there. To perform this Ohm's law, we have one activity. Okay, so Ohm's derived this law. So he derived that what is the relation between voltage and current. Listen first. Okay, voltage current is, when you increase the voltage, current also increases. Voltage means is nothing but pushing force, right? Your the charge is moving because of this voltage difference, right? Potential difference. If potential difference is more, the charge will move very fast, and the current also more. Means you are giving so much force, so that the current will move so much, the charge will move with very fast, right? The charge moves very fast. Because of that, current also increases. When voltage increases, current also increases. When you decrease the voltage, current flow also decreases, and these two are in linear relationship. Now you see Ohm's law defined like this: the potential difference V across the ends of given metallic wire in an electric circuit, which is directly proportional to the current flowing through it, provided its temperature remains the same, and this is called Ohm's law. Okay, but that means when you increase the voltage, current flow in the circuit also increases. When you decrease the voltage, current flow in the circuit also decreases. If both things are increasing and both things are decreasing, means what is the relation between these two? Directly proportional. So which indicates, directly proportional indicates, if voltage increases, current value also increases. If voltage decreases, current value also decreases. And that's voltage, how this related with the current? It is directly proportional. Now you see the potential difference V across the ends of given metallic wire in an electric circuit. Okay, so this V is directly proportional to current, directly proportional to current flowing through it. And during this experiment you have to maintain the same temperature. If temperature varies, and this relation also may vary. Okay, so every time while defining the Ohm's law, you have to write this: temperature remains the constant. Okay, don't forget to write this temperature term. Okay, temperature remains the same. And this is we called as Ohm's law. Ohm's law derives the relationship between voltage and current. Here we have some experiments also. When you increase the voltage from 0 to zero point 0.4, 0.8, 1.2, 1.6 and 1.8, and you measure the current in that circuit also, linearly it is increasing, right? So when it is increasing in the voltage, the current also increasing linearly. You will get graph like this, straight line graph. So this straight line indicates that there is a linear relationship between the potential and the current. That means here, with increasing the potential value, current value also increases, right? So in equation R, just a minute. Okay, in equation R is constant. Now you see V is proportional to I. Okay, then how we can define this? How we can derive this formula for V? So V is proportional to I. When you remove this proportionality, we can get one constant. that is this. So this by I, so let us say, no, let us say this is V equal to constant into I. So I, you take it this side, so V by equal to constant, and this constant we named as resistance, and this is resistance value is constant for particular electric component. So V by I equal to R, where R we called as a resistance. Okay, resistance of a particular wire, metallic wire, whatever you are using in the circuit, that wire. So that wire we called as that wire has some resistance. The resistance value is constant. Then V by I value is always constant. How it will constant I will explain later. Now you see, this is at a given temperature. So, okay, don't forget to mention this temperature. So and it is called resistance. So what is the R here? R is a constant for the given metallic wire at a given temperature, and also it is called as what? Resistance, right? So it is a property of a conductor to resist the flow of charges through it, and this is the definition of the resistance. What is the resistance? Resistance means it is a property of a conductor. So every conductor has some resistance. Okay, because of that nature, it resists the flow of charges through it. Is it clear, everyone? Okay.